which make it pretty pictures a little more difficult. So, Carly, why don't you tell us a little bit about your equipment while we're solving our technical.
No, it's. I'm seeing it now.
Oh, okay, we're good.
I unplugged the cable and plugged the cable back in, and then it popped in.
Perfect. Excellent. All yours, Carly.
That's Windows, right?
Yes, that's wonderful.
Thanks, Steve.
Yeah.
Yeah. Wow. I'm not as experienced as many of you here. Just started my for the journey, as Steve just mentioned, a few years back, and been trying to learn things, reading articles, looking at videos, and coming out here, talking to folks, and spending through what how I can image and process things, right? And one of the things that I sort of ran into challenges. If I have to read good images, I always have to find come out here, and I can do that with my work schedule. I can do that only like during the weekends, and then I have to read the full moon, right, and clear skies, look for clear skies and things like that, right? So it was very limited time, in a calendar year, but yeah. So I was like, how about to give up on some of this, the whole thing about astrophotography and just get that fully into bird photography and wildlife photography and things like that. Then that's when I started reading about Narrowband Imaging and how we can possibly beat light pollution to a certain extent, right? And so I wanted to, Steve and Eric ping me, because I do share some of my photographs and work on Facebook, and daily Facebook and whatnot. And so they reached out to me and said, asking if I would be interested in sharing some of the things on color and personality. Clearly, I'm not a Windows guy.
So you hit the next button. Then
Yeah. Technology for a technology guy. All right. Well, yeah,
Let's improvise.
so a little bit of shameless self-promotion. Moved to the US and been in the Atlanta area since then. Software engineer, technologist by profession, and watched Star Trek several times, end to end, the next gen as well. Space, astronomy, astrology, astrophotography, all that has been with me for a long time, for a better part of my life. I also do some birding and a little bit of painting, eye painting, whatever, whenever I have a little bit of time, but these days mostly it's astrophotography that is taking up my time. So light pollution, I just reached through some of these things. It's not about new information. Dark sky.org defines light pollution as thin-and-made alteration of the light levels. Impacting the natural environment, especially nocturnal environment, where lights from suburbs, cities, and whatnot, altering the light perception during the nighttime. And that also has its own side effects as well. most importantly for us, it's blocking view to the universe. Right? That's typical neighborhood. That's a shot from my front of the house. That's the kind of light pollution we're talking about, artificial light pollution, and then of course everyone's favorite, right? That also adds to our challenges. The moon itself presents a pretty significant challenge in the sense that it's a broadband light reflection that is reflected, meaning it covers the entire visual spectrum. So if I'm trying to image a galaxy, which is a broadband target, it's not specifically emitting light in certain specific wavelengths, right? Across, so across the EM spectrum, that adds to the challenge. Right? The moonlight just blocks out completely. So, but how do we address that? That's the thing. Right. So, light pollution, I don't want to read through this. It's pretty self-evident based on what we talked about. So, ultimately, what it means is we can have a longer exposure without countering the light pollution, that is the ambient light pollution that we have. And that means you will have washed out images, even anything more than a minute from our suburbs, right? From your neighborhood, from your backyard. Even more than a minute is just impossible, right? You just get washed out images. And so then the question really is, how do we go from this to this, right? This, for this information, this one is a 600 seconds exposure, single exposure of the SH2-174 nebula, right? That's in the hydrogen alpha wavelength, right? Using HA filter. So how do we go from there to that? So as you can see, there's using the filter, it cuts out even at 10-minute exposure, right? I don't see a whole lot of light pollution there, but the object is still there. You can't really, discern it. That's where a post processing comes into play, right? But the point is, with some of these specialized filters, you can effectively cut out. You can cut out like upwards of 90%+ of light pollution. And this also, the other thing is this was taken at 87% moon, right? And so with the filter, with a strong filter, I use a Chroma HA 3nm filter, right? And so it's pretty good in cutting out a lot of light pollution there, right? But then how do we go from that to this is still the challenge for us, right? So again, nature to the rescue here. It just so happens that a lot of the emission nebula that you see targets that we try to image emit light in specific wavelengths, right? Which actually works out to our favor from a physics and optics perspective, right? Hydrogen alpha, oxygen 3, and sulfur 2. In their specific wavelength, 650 6 and 572 nanometers. What it does is it gives us the ability to allow only that specific narrow band, and that's what it's called narrowband imaging, right? To the sensor, block out effectively most of the other wavelengths. Right? Again, when I say most, it's not 100%. Obviously, right? That's we can control that using other techniques that we go through. Right? So it also allows us to image during full moon. As I said, that's 10-minute exposure, single exposure was taken at 87 the clear sky, right? And then of course this also means that we are forced to use a monochrome camera. Although when we look at the towards the end, we talk about how that is beginning to change a little bit. We'll come to that. Right. We talk about this. And yeah, so just coming back to the equipment that I use, I have an IOPRON 770. My apologies for the typo there. CEM, not CME. But yeah, 770. The DIY body there is that. It's an Explore Scientific 127.
Sorry, I'm just trying to see what it is.
The Celestron C8 HD scope as well here on the right. Cameras, I have 3 different cameras, 2600 mm. That's not my favorite. That's a fantastic camera. I have both the mono as well as the color sensor. And then more recently, about the 533 mm Pro. It's just kind of weird. It has a squarish one by one kind of sensor.
Okay.
Yeah.
They're going to post it
Good
afterwards. Thanks.
Deep, really deep sky objects with the Celestron. And filters, as I mentioned, I have Chroma HA and O3, the 3 nanometer range. The O3 band is kind of notorious because we have oxygen surrounding us, and then so what that tends to do is blow up the stars a little bit, right? So that's something that we need to control based on things like exposure time and then post processing as well, right? There's only so much we can do there at that point. Then I have an anti-S2 filter and also an anti-LRGB filter as well. And yeah, not to mention the autofocus service. Both the scopes have autofocus and filters. So how I go about it, right? This is kind of my routine that I have tried to fine tune as I, year by year, as I try to evaluate how I am doing, what is it that I can do, right? The first thing that I go with is I constantly keep watching the weather, obviously, right? For clear skies, and then the target selection. To me, I think the target selection is really key, especially in a suburban setting where you have to contend with trees and houses and buildings and whatnot. So your target selection becomes really key because of 2 things. One is obviously the visibility, and the other thing is you want to try and maximize how much of imaging time you get on any given night for that particular object, right? If it is, let's say if you do have a clear sky, but it is too low on the horizon, like the Helix Nebula for me in the southern side, and it is right on the Atlanta Light Dome, right? I only get like 2 hours a night. That's it for the Helix Nebula, right? And so that's why I try to maximize. I'm very careful about my target selection. Right? Because all of these different parameters, I want to make sure that I maximize. I get at least 3+ hours, including the meridian flip as well, right? 3+ hours of imaging time, and that too with narrowband. Now 3 times the imaging time you have to spend. For every filter, we have to get at least 3-4 hours of imaging. So that goes across multiple nights. So that's one routine that I have. The other is obviously data, right? More the merrier, because the goal is to maximize the signal to noise ratio. Signal to noise ratio. Signal is actually the light from the object that we're targeting. Noise is just random ambient noise. Thermal noise in the sensor, heat noise in the atmosphere, distortion, what have you, right? All of that is just random noise. So the more data you keep collecting, but at one point, one of the things that's a very interesting thing is, I think it's a minimum of 300 seconds again if I'm doing, if I'm trying to image a nebula versus, with my refractor versus my celestron. The celestron is kind of, I'm not a fan of this. And simply because what happens is, because of the focal length it has 2000 mm, no matter what, even at 120 seconds, the stars are blurred, and the guiding, even with the near perfect guiding, you still have star trails just because of the focal length. Right? If I do maybe 2032, yeah, 2032 on focal length, right? So C8 is really good for planetary imaging, but for other deep sky objects, I find it a little bit challenging, especially because the stars just get bloated up at that native focal length. And if I don't operate at that native focal length, I can again miss out on a lot of the objects. Right? So let's say it's a compromise always. But yeah, so with the refractor, 300 seconds versus 600 seconds, I tend to mix different exposure times. So just to get the different high dynamic ranges of a lot of the objects, right? So at lower exposure, I can get really core of some of the core brightness of the object that I'm targeting, right? Versus the 600, what happens is obviously the bright cores, they get washed out. It's fine. But then with HDR processing, we can control that, right? So that's what. And then I also take really short RGB exposures, about 2 minutes each for the start, right? And I'm focusing. I'm only focusing on real narrowband, SHO and RGB here. I can quickly touch upon later on broadband targets also with the same setup, right? We'll look at a sample image as well. And then every session, every object, I immediately take calibration frames. A lot of articles talk about maintaining a library for a year or so or whatever. But for me, I think I felt that taking it every time I finish a session for an object or multiple nights, the first thing I do is I take the calibration lesson on the bias, the last and flats and whatnot. Right? The reason being the dust on the lenses, on the glass, and the noise, everything is all fairly random, right? And to maximize my ability to cut that off during my post processing, make sure that I get a fresh set of calibration frames every single time. I just don't maintain that. That's another. So with the imaging done across multiple nights, the next obvious piece is the post processing, which is the key of the whole thing. Right? Pix Insight I use, and this software, I'm just like I'm just blown. The first time I bought it and I started using it, I was just blown. God, man, this is unbelievable piece of software. And I've written software for all my life, but I mean, this thing is like, how do you come up with this, right? And Blink, I use one of the processing Blink to start satellite frames, aircraft frames, and whatnot. Sometimes errors in guiding. So you just Blink through that, discard some of them. Although satellite frames allow, if you have good flash and dark frames, that can still be Pix Insight still takes them out. to a considerable extent, which is really awesome. Right? I mostly use the weighted batch heat pre-processing. I used to do it the full shebang, right? Manual integration, calibration, all of that. So like, man, this every time I would do this, being an IT guy, I want to automate a lot of routine things, right? So, and then that's where a few weeks inside we use the WB, okay, let me try that. And after that, I don't do any of the manual stuff. I just select all of my subs and push it to the batch process. Just factory settings. No, I don't tweak that at all. I'm still learning, so I don't try to. I'm not trying to play with a lot of the options within the WDB. But so far, it comes out really awesome. Even the basic settings, the standard settings, they come out really well, right? And then, so coming out of the batch process, you get the master frames, and that's where you go into the post processing, right? Right. So, before we get into a little bit of my detail, this is the standard way, alright? So you get the master lights coming out of the batch processing. You get the three hydrogen sulfide masters, and we use channel combination to get the famous Hubble palette, right? Etc. Right? And the first time you do this, it's like this green thing is like, what did I do? And then you run through spectrophotometric color calibration, and you get the this is the output of this, right? You can barely make out the object there in the Hubble palette. This is the standard. This is very common, right? But yeah, we can do a lot better with it. But if you start with this and I try to pull out as much as possible, there's only so much I can get in terms of color and depth and energy out of it, right? So what I try to do is being a little bit of an artist at heart, try to apply color to this. Right? So I'm really sorry. I had one slide which talked about Berkeley, but I'm not able to open it. It's in a Mac format, and this is a Windows format. But I'll try to go through that. But here's what I do, right? So after the batch process, I have the RC Astro plugins. The first thing I do is take out the noise as much as possible. Noise exterminator. The reason I do that is any subsequent single operation I do, if I have not taken out the noise, guess what? The noise gets bigger into the image. That noise. So you want to eliminate that noise as much as possible, right? So the first thing I do always, and there are opinions about it, there are views and a lot of articles about this. But for me, I really want to cut down on the noise. So that's why I use the noise exterminator as a real first step on the masters. And then blur exterminator and then remove the stars. Right? I want to make sure that I minimize noise in the subsequent steps.
Do you ever do deconvolution before the noise removal?
I did not see a whole. I have done that, yes, but I did not see a whole lot of difference.
Or benefit? Yeah.
Yeah. Noise exterminator these days is, with all its AI features, it's pretty neat. And I can control, with blur exterminator, I can control, the star halos as well. I can reduce
So you do that later. You do the blur exterminator later, do you? Okay.
Yeah. Yep. I can blur exterminator. I can also adjust the details. I can leave the details as is or increase it a little bit. I can experiment. I don't want to go too crazy, otherwise it becomes too sharp and
That's fake, yeah.
yeah. Star experimenter, I take out the star from the master narrowband images, because when processing those, I don't want stars there because I have these RGB stars as a separate set that I use, right? And then what I do is, like, I take these starless masters and I convert each of them into an RGB. Just go to color space conversion and convert it into RGB space, flat out, right? It is still a gray, black and white image, right? But I convert it into an RGB, each of them, just RGB images, right? So from that point on, since thinks that I'm working with a RGB image, even though it looks, monochrome, right? Then what I do is create a mask for the object using ACDNR. So in ACDNR, you go in, there is a lightness preview option. You enable that. I clone, I don't have I do have the master. Yeah. So I create a clone of the master, I apply the lightness preview on that. I can adjust the shadows, midtones, and all that. So that becomes a mask. Now I apply that on the master. Invert the mask. Because when I apply the mask, it is protecting the entire image except the object. So when I invert the mask, now it's going to let's say that backwards. I think it's backwards. Yeah. When I apply the mask, it is protecting the object, but the background is unprotected. So I want to revert that, right? So I want to unprotect the object and protect the background, right? Because that's key, because in the next step what I'm going to do is I'm going to take that masked image and using curves transformation, I start applying colors. I start pulling out the colors. Now, HA, we know, is pretty important. Visually it is, in a false color sense, it is reddish, right? So for the master HA, I treat the RGB channels in curves transform to get it to a golden yellow hue. Like if anyone is doing solar photography, you can see that the golden yellow hue of the sun, right? So that's what I try to apply to the HA. And I talk about why I do that, right? And similarly for the sulfur master, I do I bring it out into a reddish orange kind of a hue, right? And oxygen is bluish teal color, right? So with that, then what I do is I remove the mask, take out the mask. So now the object is in a golden yellow, reddish, and in a bluish tinge, three of them RGB, right? So now I can go in and combine those three guys using pixel math, right? I can just do a straight SHO with that, right? Or I can do a combination of, I can apply different formula, I can tweak the intensities, and I can really play with that, right? So what happens is, I mentioned earlier something about color theory, right? So if you look at this, what happens is either a pixel is a red or a blue or a green, right? Straight coming out of channel combination. So that's why it seems totally flat or whatever. But with tweaking the individual channels here and the color hues, I'm effectively kind of painting and blending the colors, right? Wherever hydrogen is prominent, right, that takes the reddish hue, and wherever O3 is prominent in the data, right, it starts taking on a blue. But if there is a boundary there, it kind of mixes and gives you that rich color and also depth, right? So that's where I try to apply the color theory a little bit there. And then I use the local histogram equalization to increase the sharpness and the details a little bit. This is a fairly simple process that I follow. There's a lot more complicated workflows that a lot of folks use, and that it comes out really well. But for me, I think I'm really happy with what I get out of this. Right? That's just me. That's all. Right? And then I take the export the TIFF into Affinity Photo. Yeah, I don't use Adobe. I don't want to pay monthly for that. This was a one-time purchase, Affinity Photo. It's fantastic. It's great for my wildlife photography processing as well as the images coming out pixel side as well. So and then I make more adjustments to that in terms of brightness and noise and details and things like that. So we talked about the pixel side process, right? The pixel math. So this is what is effectively happening here. If you see, stand here. So for the red channel, what I'm doing here is I am blending the oxygen here and here the first part, enhancing the oxygen, and then blending in the sulfur hues there, right? And then adding the HA signal, which is the same thing, right? So it acts as a, to give a little bit of physics or color theory background here, acts as a conditional blend mask, right, from the O3 structure, right? What it does is, optically, when the human eye, anything that is closer is slightly brighter, right, and anything that is farther away is slightly cooler, right? Closer is warmer, further away is cooler, right? So what this does is, this combination does is, anything in the hydrogen and sulfur are the same. It kind of brings it out, it pops it out, right? So what it gives us a perception of depth during a variation, right? And we'll see in the actual image itself. And that's what this particular thing does. And I've been thinking about kind of writing like a script or whatever, where we can drag it around in real time to make it a little bit more fuzzy. You can vary the percentages and whatnot on how much signal strength you want to mix it, right? So that's always there. This is what I get. So this is the after doing all of this. This is a standard SHO, right? After having converted the masters into RGB and applying the curves transform for the three images, and I just take them into channel combination, I get this. But if I do the pixel math, I get that. Right? So that's the two different views, two different takes on the same image. But yeah, I can see here, actually both of them. You can, if you look at the original image, you can feel the depth perception when you're looking at the image. And to me, that's what is really interesting, right? And the SHO version of it, you get that really fiery, reddish orange, yellowish hue, which is what I imagine it to be, because after all, nebula are result of stellar explosions and whatnot, right? So that's what this thing highlights for me, right? This is as far as your emission targets are concerned, right? You can do a similar thing with galaxies or broadband targets too. But here it's slightly simpler in the sense that I'm using LRGB images and then a little bit of hydrogen as well on the M101 here, right? Similar workflow, but instead of the SHO, just go through the once I convert that into I don't need to convert it into RGB space because it's already RGB, right? So I use GHS, generalized hyperbolic stretch, to stretch it out and use LRGB combination to combine that, and then narrowband, broadband to combine. Right? So very similar, but not really pixel match, not because it's native RGB images.
It's a bad connection. It's not good.
No, I think it's his power savings.
No, it's too hard to figure out. What, you want to look at for more than 2 seconds?
So you can see that in M111 with the hydrogen, so you can see a lot of the nebula and gaseous emission target there. Of course, it's 13 million light years. Yeah. So we can't really image those nebula. So why this works? I think it talks a little bit about the color theory here, right? Is color mapping aligns with a lot of the key the mixing aligns with a lot of the key principles of color theory. Red and blue, right? They form an opposite on the color. If you look at the color wheel, they are on the opposites side, and this maximizes that depth perception. Right? That's where this if you look at this here, you can see almost that there's like a difference between the underside here versus this guy. That guy is slightly farther back, whereas this one is slightly closer to you. That's what that perception is, right? And then the transitions create a gradient rather than an object either the pixel is a red, green or blue. It kind of gives you that blended view, right? And then, of course, there's also the human perception aspect of it from a psychological point of view. The warm views come closer to you, whereas the cooler ones are back, right? Which is what a lot of artists use as an underlying theory in their paintings. So a lot of the if you look at a lot of the old fine art paintings, if you closely observe, that's what they do. Even though the two brushstrokes are side by side, just because of the warm and the cooler thing, and if you stand back and look at it, you see that it recedes, whereas the warmer one is advancing to it. Right? So that's what that does. A little bit more on color theory here. I don't want to dig into that. So that's what they are. This color wheel represents the red and the blue are on the opposite sides, and the green. The mixing really pulls out that perception, right? In line with how the human eye perceives color. And with all these things, I talked about something earlier. I kind of indicated something. This is the new set of things that is now coming up in the market. I just got this. I've not tried this yet, but the looks of it and the reviews seems pretty promising. Apparently you can do in narrowband with one-shot camera, because there are two filters in this package. One is a HAOT filter, and the other one is a S2 OT filter. Right, so it will be interesting to see how I can process it and what are the details you can get. I don't know if anyone has already used it here, but I'm not yet tried. I've got it. I've not even opened the package yet, but got it very recently. But
think Optilong sells one now too.
Yeah.
Optilong sells one now too.
Yes,
It's just too.
Optilong also has one. Yeah.
People have tried that in the past. The problem with color cameras is you lose a lot of contrast.
Yes.
So you're trading a little bit easier image flow for a lot less contrast.
You can fix that though, to some extent.
Yeah,
Some
you can
extent.
probably do a little bit more of the luminance channels and get a lot more detail.
That's what curves is for.
Yeah.
Thank you.
Thank you, Carly. Anybody have any questions?
I have a question. Do you take advantage of the gradient correction tools much?
Sorry?
Do you take advantage of the gradient correction tools?
Yeah, I applied. Sorry. Yes, that's even the right out of the processing from WT.
It's just a little small. I couldn't see it. I'm sorry.
I think I missed that out, but yeah, gradient correction is one thing, or dynamic DB, dynamic background extraction.
Yeah, but the new ones, like the multi-scale gradient correction, where they have sort of reference images,
Yeah.
I find to be absolutely priceless.
Yeah.
You do it before noise, doing the noise one? Or
Yes.
after?
Yeah, I do it before the noise.
Okay.
Gradient correction, I do it before the noise, and then I give it.
All right. Any other questions, concerns, emotional outbursts? Been a long week. We all have dark sky fatigue. It's been such good weather this week. I think everyone's tired. We've all been up till 4 o'clock in the morning most nights.
Everybody's fried.
Everybody's fried. Okay.